All right, some more examples on changing repeating decimals to fractions. Okay, so again, this is repeating. So there's two different digits that we're repeating. So when there's two different digits, we're going to multiply it by 100. So it moves at 2 decimal places. This becomes 100x equals 364.6464, right? I just write this several times to remind myself that it's there. We're going to subtract, that is my daughter's foot there. All right, we're going to subtract the original equation, 100x equals 3.6464. 100x minus 1x is 99x. Over here when we subtract, again, I like to cross those off. It just makes it a little bit easier for me when I'm seeing the subtraction. I'm lining up my decimals. 4 minus 3 is 1. We've got 6 and 3 still here. We're down to a one-step equation. 99x equals 361. We're going to divide what's in front of x, so in this case 99. So we get 361 over 99. Again, for what we're doing right now, if you can get me to this part, I'm super excited. If you can get me to the next step, great. But it's okay if you can't. This is a mixed number. Our numerator is bigger than our denominator, so we have to divide this out. 399 can go into 361 how many times? When I'm doing this, the trick is I'm looking back up here. Okay, hold on. She needs to say hi.
Hi.
And then we can keep filming. All right. This is a 3. I know that 99 is going to go into 361 99 times. Those numbers are always going to match. Okay? So 99 times 3 is 27. Carry 3 times 9 is 27 plus 2. So it's 297. I'm going to subtract 297. 11 minus 7 is 4. I got to borrow from this. 15 minus 9 is 6. So I'm left with 64. So when I write this out, 3 is my whole number. And I'm left with 64 over 99. Again, for my students, I would take either of those. Okay, let's do another one. Let's do this one. X equals 4.2 repeated. So again, when we're doing this, we want to see how many different digits are repeating here. It's just the 2. When it's one digit, we're going to take it and we're going to multiply it by 10, right? So you're always multiplying by 10, 100, 1,000. You're multiplying by powers of 10 because it moves the decimal without changing the number. This becomes 10x equals 42.222. Again, I just list several of those so I know it's there. Subtract the 1x equals 4.222. So, again, I put the 1 in there just so I remember it's there. I'm lining up my decimals here. 10x minus 1x is 9x. 42 minus 2. Again, let's cross those out so they're not in our way. 42 minus 4 is 38. We're going to divide by whatever's in front of the 9. And again, if you can get me to this point, 38 over 9, that is fantastic. If you want to try to change it into a mixed number, you can. So again, numerator goes on the inside of your division, denominator on the outside, 38 divided by 9. This is our clue. This says 4, so I know that 9 is going to go into 38 4 times. 9 times 4 is 36. I'm subtracting 36. I'm left with 2. And then I can write this out. So x equals 4 and 2/9. And again, and that's how you change repeating decimals to fractions, right? Because we can change a repeating decimal to a fraction, that means it's a rational number. Any number that can be written as a fraction is a rational number.